Hello, everyone. We are the group that was tasked with finding an article relating to the impact of beetle outbreaks on forest structure. The article we chose, Comparison of Riparian and Upland Forest Stand Structure and Fuel Loads in Beetle-Infested Watersheds, Southern Rocky Mountains. The purpose of this study was to compare the forest structure characteristics and fuel loads of riparian and upland forests disturbed by mountain pine beetles and spruce beetle infestations. The researchers felt that this was an important topic to study because they did not find that there was much data available on riparian areas affected by beetle infestation. They started with their site selection by finding 30 riparian sites. Each site was then matched with an upland plot that was located within 400 meters of the riparian plot. All of these plots had to have greater than 50% beetle infestation. They took a lot of different measurements for this study, both for forest structure and to determine more information about their fuel loads. The results. So what they found is that forest structure characteristics were statistically similar, as well as fire load characteristics and amounts were statistically similar between the upland and riparian plots. They did see that riparian and upland ecosystems had become increasingly similar post-beetle outbreak. However, they predict that they will start to differentiate as time goes by due to differing in management techniques between riparians and uplands, as well as different fall rates of the different tree species that predominate those areas.
Previous and recent management strategies. The previous management strategy for upland stands within the last 50 to 60 years included selective thinning. For riparian areas, it was more difficult to determine what strategies were used exactly. However, old growth was avoided and selected riparian sites were managed from indications of logging activity. More recently, in upland stands, salvage logging treatments have been conducted in response to high levels of MPB mortality. In riparian areas, fuels reduction treatments are being applied.
In their paper on beetle impacts to riparian and upland forest, Higgs et al. Raise a few issues for future research. They call for increased research into the effects of fuel treatments on riparian systems. These systems are crucial to ecosystem function and experience comparable canopy mortality and fuels loads to upland systems. Higgs et al. 2018 state that, quote, limited knowledge combined with administrative regulations for riparian management presents additional challenges to resource specialists planning fuel treatment projects and other management actions in beetle-infested watersheds, end quote. Higgs et al. Present past research into fuel moistures, but state that additional research is needed to compare riparian and upland forests. Knowledge of fuel moisture differences may be crucial to understanding how riparian and upland forests burn. Finally, the authors suggest that future research should expand on their study with more samples and larger plots.
Considering this article appears in the Forest Ecology and Management Journal, and the fact that it was funded by the U.S. Forest Service, it is pretty clear it is geared towards forest managers. Seeing that the study took place in Colorado and Wyoming, we can assume that it will be most useful for local organizations such as Colorado State Forest Service and Wyoming State Forestry Division. The study provides a significant amount of baseline data that could be used by members of academia and landowners who are trying to study and understand local forests. The specific nature of the paper, dealing with riparian ecosystems and fuel loads, make it clear that this information is particularly useful for people studying and managing forest fires and local streams.
For the paper's main strengths, first, the author developed a repeatable, well-structured methodology which could be used on larger landscapes throughout Colorado and western forests impacted by bark beetle outbreak. Secondly, the authors used population counts as well as transects to measure tree composition and density, basal area, fuel loads, and understory brush to provide abundant data. Finally, the authors have provided relevant conclusions which could have implications to processes of management of riparian forest stands impacted by bark beetles. On to weaknesses of this paper. First, the authors relied on certain assumptions about cause of tree mortality and amounts of shrub fuel load, which could have been improved upon with research data. Second, the discussion of fuel moisture levels had implications to the study conclusions, but the authors did not provide any data from their study to support this and could have benefited from field data on fuel moisture levels. Finally, the authors could have tweaked some tables and figures to help with clarity, as some figures were difficult to read at first pass.
This paper ends with a useful section on implications for land managers. One suggestion includes development of riparian BMPs to guide land managers in conducting fuels treatments. These BMPs would ensure compliance with current regulations while still allowing for habitat protection from intense wildfire. A second recommendation focuses on recognition of future subalpine fir dominance. Increased canopy mortality of Douglas fir and Engelmann spruce due to beetle outbreaks may allow subalpine fir to become more frequent in stands. The author suggests considering this fact in restoration projects and management plans.
The article mentions several implications to natural resource management. To start off, they mentioned the importance of riparian areas for water quality maintenance, habitat for aquatic and terrestrial biota, and stream bank building and maintenance. One beneficial outcome of canopy mortality in riparian areas include increased recruitment of large wood to stream channels. Large wood shapes channel morphology and channel complexity. It also shapes the geometry, number, and distribution of pools, which creates a diverse aquatic habitat. Future fire management and installation of BMPs. Most treatment for fuels reduction and salvage logging occur in upland areas. This calls for concern about fuel load distribution and potential fire behavior when riparian areas are not treated, as they can be more intense and severe around streamside areas. Managers need to develop and implement additional on-site BMPs and riparian-specific precautions to protect the streams and other riparian functions. Implementation of BMP and establishment of riparian buffers have been known to decrease negative effects of forest harvest activities on surface water quality. However, more studies are needed to know more about BMP effectiveness in protecting other riparian functions.
David previously mentioned that this paper's implications can directly influence fire management officers, and this is where we have directly observed in the field, both in the fuels and fire suppression realms. So we have two examples. First are the hazardous fuel reduction and targeted species mortality projects in the Caribou-Targhee National Forest. This consists of mechanical thinning and burning of subalpine fir in controlled fire use units to reintroduce fire as disturbance. In many areas throughout the CT, subalpine fir is dominant due to lack of allowed natural disturbance coupled with widespread beetle-killed lodgepole pine. These projects attempt to mitigate the increase of all fuel size classes from the amount of standing dead and dead and down lodgepole, as well as the widespread dominance of the very fire-sensitive subalpine fir. This dominance has negative implications because fir-dominated stands promote highly destructive stand-destroying fires due to its thin, flammable bark, low-growing and dense branches, highly flammable foliage, and the tendency to grow in dense stands. The second example is the Badger Fire of the Sawtooth National Forest. This is a large fire incident that began burning last month and burned primarily in timber, where beetle-killed lodgepole pine contributed to much of the fuel composition, shifting from a primarily vertical to a horizontal fuel distribution and much more continuous fuels mosaic. This allowed for easy group torching, crown runs, and high heat and surface fuels, which is typically infrequent.